Okay, we were discussing about the design of isolated footing in my last part of safe tutorials. I was not able to discuss in detail because of the recording issues. Okay, now let's see the same problem. I just open isolated footing design. Okay, open. Anyhow, it is here. Let me open a new file, new model. Open. I start from scratch. File, import save.f2k file and mat footing.f2k. Open. So these are the coordinates. Let me save for this model for an isolated footing tutorial 2. Save. Okay, so I was telling you how to draw the areas, and I told you I was not able to find how to quickly draw slabs. This is the option by which you can quickly draw the area objects. All your reactions are exported over here. Okay, if you just go and show loads and select the load, live load and above, show loading values, and see these are all the loads in the live load, horizontal and vertical directions, and the moments, because all the supports were fixed support. Okay, now we are designing our footing, and this footing is going to be the isolated footing. So first thing, we have to define the define materials. Okay, C330, we can modify the same material. I say C20, and this is around 21,000, 0.15, and then 30, and let's make it 20. Sorry, 20, and make it okay. So this is a new material, and then define slab properties, add new property. This is going to be footing, isolated footing. Select the type footing, give the thickness like, okay, 300. Let's try with 300 and make it okay. Okay, define slab beam properties. There are no beams, and then column properties. Yes, there is a column above. You can add a column, add new property, column 2. Column, you can tell here this, say column 450 by 450. You can choose the same material or different material. If your column have the different material, you can select it, and you can give the size of column like 450 and 450. Okay, and you can check this, include automatic widget zone area over column. If you are designing the slab, you can go for this. Include automatic drop panel over the column if there is a drop panel. Anyhow, for this case, maybe there is no need. We need this column over the footing because we want to calculate the punching shear. So if you give the smaller size of column, it will be like 300 by 300. You can select the different shapes of column. If you give a smaller size of column, it will be more critical for the punching shear, and you can say okay. And if there are many columns, you can define as many columns you want. Let me change the size here as well, because I have changed over there. Okay, and then define. If there is a wall, you have to define the wall. Soil subgrade properties. Here we are going to define the bearing capacity of soil. I say it's QA, and I told you how to calculate it in the mat footing. It is the basically modulus of subgrade reaction the allowable bearing capacity divided by the allowable settlement. So I calculated it. For example, allowable bearing capacity for our soil is around 200 kilonewton per square meter, and divided by the 25 millimeter. So if you say for the 25 millimeter, it will become how many meters? It will become 0.025. Calculate around 8,000. Okay, and okay. For mat footing, the allowable settlement is 50 millimeter, and for you can consider 50 millimeter for mat footing, and you can consider 25 millimeter allowable settlement for the isolated footing or combined footing. Then make it okay. Define. You can define the load patterns. Load patterns are already here, which you have already considered. Then define load combination. Here you can define one service load combination, because we have to check the size of footing on service load combination. Okay, that, and then this is going to be surface finish, and this is going to be wall, and this is going to be the live. That's all. And then make it okay. And then there is one more combination for the 1.2D plus 1.6L, and then should select that. First just select the loads, then we will give their factors, wall, and then live, and give here 1.2, 1.2, 1.2 and 1.6. That's all. Okay, so your load combinations are here, and you can, if you go to add a default load combination, you can select like which limit state you want. If you are designing, then you have to according to ACI code, you have to check for the strength ultimate load combinations. Okay, and then once you have defined, now the turn is to draw. Okay, display, you can select, you can go to the XY, and this is your all display. Now you want to draw the slab, so you can quickly draw the slab by this option. For example, if you want to draw here a panel which is not, for example, which is having dimension along x-axis like 0.9 meter, and here around, okay, let's give the same size like 1.2 meter. Okay, I'll tell you later on how we can change the size. 1.2 meter. Okay, trim, and property type footing, which we have already defined, rectangular slab or circular slab. Again, type it is slab, and then we can just click and it will draw it like this. And this one, this one, this one, this one, and this one. Okay, this is the shear wall. Here we can draw a bigger area in which we can use this tool to draw. Okay, 3.1 meter, let's make it 3 meter, and 4 meter. Okay, so now I have drawn. Now for example, if this is a property line over here, you can change the size here by clicking on the joint, and then just right click, and then geometry and coordinates. Click here on the coordinates, and now for example you want to move like half meter on the inner side, just make it 0.1, and you can say it is like if you want to move half meter on the other direction, it will be 16.6. Make it okay. See, it is moved. But this joint, again you can right click here you can move it like, if for example, if you want to move like this 24 meter and 16.6, make it okay. Okay, see, similarly you can also move this joint 0.5 meter, edit 25.1, and if you want to move the vertical one, you can again move it, okay. And similarly this one, you can move it like 24, okay. So this way you can change the size. And if you want, for example, if you select this and you want to increase the size in all, if you want to have an equal increase on all sides, you can just go to edit, add select the area, select this area, go to edit areas, and expand or shrink area. If you give the positive value like positive 300, it will be expanded equally in all directions like this. So it depends upon where is the location of your property line. If your property line is here, you can change the coordinates of all coordinates like this, or you can draw here by giving the let me save my model, by giving here the different size in the x and in the y directions, okay, and you can edit them. Okay, so this is, now we have defined the slab, and this slab has the material properties which we have already discussed. Okay, next is the assignments. In for mat footing, I have experience with this version of SAFE, that it automatically take the loading from joint and apply it to the footing. But for the isolated footing, I have observed that there is some problem in the load transferring from joint to the footing, so it is better to apply these loads manually. How you can apply loads manually? I tell you for the one footing, and rest you can do it by yourself. For example, just go to this, select this joint and see the loads. So these are the different loads which are present on this joint, and we are interested in live load. Okay, the maximum live load will be in the gravity direction, so this is going to be the critical one, 866. X and Y direction loads are very small. These and movements, okay, it's up to your choice. You can pick this value of movement, and you can pick this value of live load. Similarly, you can go to, now keep this value. You can open a new file here, or you can see the reaction from SAP. Let me make a text file here, or let me make an Excel file here. And now I go to the model, I select the joint, for example, okay, select this joint, loads, these are the all loads. Okay, I'm not able to select the load, but I can keep these values. For example, I want this value of there is one more way. Go to file and go to export, create report, print tables, assignments, just 1 minute. Wait. Okay, what I want to do, I just want to select the loads, that live load above, that above, and then wall and surface finish load from above, and keep it okay. And then I want the spot assignments, make it text file, and then you can export it. Actually it is going to print, there is no PDF here. I'm sorry. Okay, let's try with this. So here it is exported. Let me go back. What I am doing here, actually I want to save these loads, these joint loads and these loads, and I have to reapply. For example, for the random case, let's pick some values. For example, in the Z direction, the dead load is 542 and surface finish load is 550. So you can say around 1100 kilonewton, and this is the wall load. There is no wall load here, almost no wall load. And then force in the global earthquake, no need to consider. Okay, live load above 900, 1000, around 1000. Okay, so you have to select this area, go to assign load data, and here you can assign the loads. In this case, if you select the surface loads, it will give you this option. It is the uniform load, but in our case our load is not going to be the surface load, so you select this area, go to assign, and then you can assign load here, surface loads or temperature loads. Before assigning the loads, what you have to do, you have to place the column here. So select draw columns, and this is the column, it is above, and if you put it here like this, it is going to be the column 1. But in our case, just 1 minute, edit, undo. So in our case our column is not this one, so draw columns in plan and select the column which we have defined, like 300 here. Put this size everywhere, and later on you can change it. Okay, now you can select this column, go to assign load data and point loads. Here you have to give the dead load. For example, dead load you can give maybe in dead or above or dead. Okay, here you give the load in the Z direction as 500 kilonewton for this one. Assign load data. Let me select the column here. Assign point loads, and then you give here dead above is here, and then you can give the live load for surface finish above, like 500. Okay, and then you can go to assign. First you have to select it. This mistake I do, but you don't repeat this mistake. Assign load data, point load, and live load you can give here around 1000. So now you have assigned your loads. Okay, size of load for punching here you should give here this again 300 and 300, make it okay. Okay, so here you have assigned the load. Now you have to assign the soil supports. Select all the areas where you want to check. Go to support data, go to soil load data, so support data and soil properties, go to QA and assign it. So your load is assigned. Now you have assigned the load, you have assigned the, you can define the design strips. Edit, go to edit design strips in X, make it auto. Okay, go to edit design strips in Y direction, B, auto. Okay, you can edit these design strips, delete this one, these two, and these. So whichever you don't want to keep, just delete that strip. Okay, okay, and these two. Okay, now you can run analysis and design. (3D) I have maybe in the column property, if I go to display, show reaction forces, soil pressures, make it apply. What I could see, actually I have done one basic mistake. When I was drawing the column, I select this option, that column is, this column property has drawn below. This column property should be above. For example, let me make it unlock. If I unlock it, and if you select X, Y, so select properties, column property, if you select all these properties and then delete it. Okay, I have to draw the column, and this column should be above. It should be 0, and this it should be 4 meter. Okay, now here click, sorry, give the plan. Okay, column 300. Okay, now click here. Just place your column here. Let me see what is the problem with it. Go to XY, draw. Okay, and property above column 300 and height above 0. Okay, property below none. Okay, now click here and you can draw it. Okay, in this case, as I'm just doing a tutorial, you can give the different column sizes at different footing levels. And if you want to assign the load, go to assign. First go to select properties, column properties, select this column, then go to assign, and go to assign to group. Here you can define groups and you can apply the load in the form of the groups. But if you want to select this, if you select this joint, and if you select all the joints, for example, let me solve these two columns. I go to assign, load data, point loads, and I keep these loads over here in the dead loader above, assign. I again select, sorry, this one and this one, assign, load data, point loads. Now the dead load, okay, I give all dead load over here like 1000 and make it okay. And now our design scripts were already defined. Now go to run, analysis and design. Okay. There is no property here. Okay, let's see the punching shear. Okay, punching shear design, it is showing here. Okay, this is the way, but I could not find the accurate results in this way. Maybe there is some problem, or in this version it is for the isolated footing, as they have given a new kind of template. For example, they have given a separate template to see the effect of single isolated footing. You can click here, single footing, and then you can give the loads, all loading values here, dead load and live load, and then left edge distance, like the size of footing 1.2 meter, 1.2 meter, and or 0.6, 0.6, 0.6, 0.6. Load size square, if load size square is it's 300. Modulus of subgrid direction, you can take 8000. Footing thickness, okay, let's say 600 and make it okay. So this is your isolated footing having all the things. Now if you just run material properties you have not defined, you can go here, you can see the material properties, assignments, footing, it is footing, modify and show property, footing, material C30. If you want to change the material, you can add new material and you can change it. Just make it okay, okay, and then assign. So all sports are already assigned, and then run. Simple. Okay, these are the results for your footing. You can see the displacements, and these are very heavy displacements, around 88 millimeter. Okay, let's see the pressure. Display, show reaction forces, apply. Okay, oh, pressure is very high. It means that the size of footing is not okay. You must have to give a bigger size. So how much is the size? Minus 0.6, and this is 0.6, 1.2 meter the size, which is not enough. And if you see in the punching shear, 0. In punching shear it is safe, but in the footing it is not safe. Now you have to revise it. How you can revise it? You can go here and you can click and then geometry and make it 1, 1. Okay. Or there is another way. If you go to edit, undo, select this area, go to edit areas, expand or shrink areas, and let's expand 500 millimeter on each side. Okay, now again run the analysis. Oh, now now let's see the pressure. Apply, close. Okay, now the pressure is less, 222 kilopascal, and our allowable is 200. Still not okay. You can further increase the size of this footing. You can just unlock it, edit, select this, go to edit, sorry it is not selected, select, edit areas, expand and shrink areas, and further expand by 200 millimeter on each side. Okay, now again run analysis. Now the further it is display, show reaction forces, apply, close. Okay, now your pressure is okay. Pressure is okay. Display, show punching shear. Punching shear is now critical. It means your slab is failing in the punching shear, and you have to increase the size of the footing. How you can increase the size? Just select here. Go to, but before you have to unlock it. Select assignments, footing, modify, and make it 750. Okay, 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 and run analysis and design. Now go to display, show punching shear design. Now it is safe. So this is the way how we design. And if you see display, design, reinforcement, but before you have to provide the stirrups. There are no design stirrups here, so that's why it is showing this type of top and bottom steel. Anyhow, you can draw the design strip, like edit. Okay, okay. The maximum steel is near the column corner and the edges. These are your strip forces. If you go and click on 3D, you can see. So as you are moving away, it is reducing. But the point is here that it might considering the original size, so you have to check for the revised size, and you can do this modeling again by defining a new template like single footing. Okay, keep these values, make it 1.2, 1.2, 1.2, 1.2. Node size you can give 450, 750, 8000, and okay. And then you can do it again. Slab property you have to check. Assignments, footing, okay. You can modify the material. If you are okay with this material, it's your choice. Okay, okay. Run analysis and design to save. Okay, so let's see the display, show punching shear design. Quite safe against punching shear because now I have increased the column size. And display, show reaction forces, soil pressures, apply, close. Soil pressures are also okay. Now your design is safe. And if you go to display, show slab design, this is your FEM based analysis results. But if you want to see strip based, based upon the strip, you can click here. If you choose, okay, keep it 1. Now you can see it is all over the bed, because in that case we have expanded the area, it was not taking the effect. And if you go to design, display, layer B, strip base, now you can see the layer B. That's all. So this concludes this tutorial.